So hello everyone, welcome to our channel Electronics on Wheel and thank you for your support. So in today's video, we will keep the target of 100 likes and 100 comments. I used to make the videos whatever you have asked. So here was the request came from you only. So Parik has said that could you please make the video on the seal date can be used for the EMI and EMC effect. So in wiring harness, how we use the seal for the EMI and EMC effect we will see in this particular video. First we will try to understand what is the EMI and EMC effect, and then we will go to the mitigation where we will see that how to mitigate those EMI and EMC effect through the cabling, shielding or twisting. We will see those things. Then Bhavna also asked the same question, please make video on EMI and EMC. Then let's move to the EMI and EMC effect. So first we will try to understand what is the EMI and EMC effect. So EMI is nothing but electromagnetic interference, and this is the problem. And EMC is nothing but the electromagnetic compatibility, that is the solution. So first we will try to understand the what is EMI. So as the name suggests, electromagnetic interference. So you know the electromagnetic field are everywhere wherever the current is flowing through the wires, right? So if the current is flowing through this wire, then there will be always electromagnetic field in the form of magnetic flux lines or electric field in the E field surround the conducted medium. And because of that particular electromagnetic field and the electric magnetic field or electric field, that this is the unwanted signal you can see here. So suppose one current is flowing through one wire, then there would be a unwanted signal or noise because of this magnetic flux and electric field. So that particular interference create a problem in the circuit operation. So suppose what problem creates, suppose you are taking suppose 2.5 and 0 volt as a 2.5 you are taking as a high, and 0 volt you are taking as a low. Suppose I am taking one example of digital, and suppose because of this particular magnetic flux, this particular range goes between 0 volt to 0.75 volt, because it has attenuated, this noise has attenuated this high signal. So what it will consider is as a low signal. So suppose the output is high, but it is considering as a low signal, that is a problem for the output, right? Then operation will be affected. So that is the problem of EMI effects, electromagnetic interference. So signal plus noise, if noise is into the signal, then it can change your output. Then what are the examples? So suppose DC-DC converters. So DC-DC converters are used in the electric vehicles nowadays. So they have the high voltage and high currents, and even high frequency also. So these are the effects where high frequency and high voltage are there, are more prone to be happen. So EMI can cause the problem within the system generated. So what does it mean? So suppose you are a DC-DC converter, this is one particular device. So this particular EMI can create a problem in this output of this particular component itself, DC-DC converter, and as well as in other completely unrelated system. So suppose one particular system is antenna, or suppose you have the some function of, you can take any example of radar suppose. So if you have the EMI effect here, then it can also affect to this particular radar component as well. So this is the meaning of EMI can cause a problem of within the system generated or to the surrounding as well. So EMI can occur, on a regular intervals also, or it can be occur in a random way, right? So this is the thing which makes EMI to identify a really time consuming task, and it requires the text equipment like a spectrum analyzer, which is used to identify the particular EMI effects. So there are two main ways of EMI may transfer to another system. So first is the conducted and second is the radiated system. So radiated system or radiated emission usually come from the signals operating at radio frequency like microcontroller data lines, clocks and wireless transceiver. And conductive emissions can occur from the inductive loads, capacitive, common impedance. So wherever you have the motor, right? So there is a high chances you will be having the EMI effect, because that is the inductive load. the noise artifact interfere with the other system or the functions. So crosstalk between the signal lines by either the inductive capacitive coupling is the another term used to describe the EMI. So sometimes if you are someone is saying crosstalk is happening between the signal line, that means that EMI is taking into the role due to the inductive and capacitive load. So in car, what are the internal EMI sources? Can be like fuel control system, CAN buses, electronic braking system, power steering module, navigation radio combination, airbag inflator, adaptive cruise control, and wherever you have the inductive and capacitive load, starter motors, right? So all these are the cases of, and DC converter where you have the high frequency high voltage, right, and inductive and capacitive load. So these are the internal source of EMI. Then what are the external EMI source? They're like cell phone, high power transmitter, Bluetooth devices, remote entry, third party navigation. So all these are the external EMI sources. So these are the sources of EMI, and I hope you understand what is the EMI, what are the example of the component where it can occur, then what are the ways of communicating the EMI from one system to other, conductive and radiative. So you can see here, this is the same thing, like here you have the receiver, and this is conducted through the direct through the wires. This is the one way. Then you have the capacitive element. Due to that also it can affect because of magnetic field and electric field. Then inductive load also, you have the suppose here it is the primary winding and here is the secondary winding, and around this the magnetic field will generate, magnetic and electric field will generate, and it can affect to the nearby system also and within the system also. Then radiated, as I already told you, that radio wave frequency where you have. So this is the few examples of electromagnetic emissions. So I hope you understand the problem, how it is happening, EMI problems, and what are the causes of EMI, then how to mitigate that. And in mitigation, that EMC is comes. So EMC is nothing but electromagnetic compatibility. So the component which are compatible with the electromagnetic issues, that is the solution for that, right? So there are two types of critical aspect of EMC in electric vehicle. So electric vehicle, I'm taking because in most of the time if you see in electric vehicle, we are working on the high voltage, right, in high voltage harness. So as I told you, the EMI is more susceptible in the high voltage systems. Okay, high voltage high frequency. So this is the one example which I taken, that in electric vehicle, sorry, the first involved in ensuring the circuit capable of generating any form of EMI do not conduct or radiate interference. So first thing is, you should ensure that circuit which you are using, that it should not conduct or radiate the interference. The second thing, if suppose is happening, then how to protect, okay, protecting the system susceptible to EMI. So here it will come, which I told you, like shielding and twisting. So suppose you have the system and it is creating the electromagnetic effect, then how you can save your system or how you can mitigate those effects. So what are the standards which we are using? So EU ECR10, CIS PR25, ISO 114512. So these standard I will put in the Telegram channel. You can check out those, where you will get the test procedure, how to do the EMI and EMC test procedure, what are the criteria. So in Telegram, I will put the link in the below in the description. You can go from that link to the Telegram and join that, and you can get that particular ISO, and you can download from the Google as well. Not a issue. In most countries around the world, these are the standard which are using. So these standards cover the EMC susceptibility from the sources within the vehicle or external. So these are the two example which I have given you as a solution. So suppose this is one PCB1 and PCB2, right? So here I am giving the example of within the system, right, how to mitigate. So this is the cable shielding, this is the wire, gray wire, that is cable shielding, and this cable shielding is actually given as a grounding purpose. So this is the conductive loop enclosure, one from one point it is going to here, and this is the 360 termination if you see, and here it is the effective grounding wire. So this is the one way. The second way is, then you have your cable, and your chassis always will be on ground. Okay, then you have your metal clip here, metal clip clamp and exposed shield. This is the shield. I will explain how this shield is work in the next slide. I will tell you in detail. Then this is the metal cable clamp. So this particular shield, actually what we are trying to do with the metal cable clamp, that we are trying to ground it, so that whatever noise or unwanted signal is there, it should grounded. Okay, so let's go to the what are the practical example of the EMI EMC mitigation. So there are two ways to mitigate the EMI effect. One is the shielding and other one is the twisting. So today we will discuss about the shielding, and in next project or next video we will see the twisting also, how twisting can overcome the EMI effect. So shielding is the best possible solution to reduce the EMI effect. So shielding, what it does, so shielding works in two ways to mitigate the EMI. So suppose this is my shielding. Okay, this is so actual shielding how it looks. This is the shield. Okay, this is the braided mesh shield. So what happens when suppose the unwanted or incident wave comes to this, that it will reflect back. So first this, what it does, what shield does, that it will reflect the unwanted external energy. This is the first work. Then what it does, second thing, it can pick up the unwanted signal. Suppose something is left out. Okay, so here it is coming after reflection, somewhat it is coming, and here it is coming. So something is left out, then what it does, it will have a drain wire and it will ground it. Okay, so unwanted noise and energy sent to the ground. This is the second work of the shielding. Okay, so EMI does not reach the conductor by this particular EMI shielding. As I told you, two work it does. So suppose even if goes, so some energy will still pass, right? You can see here the transmitted waves, the second transmission wave, so it still pass through the shield, but it is so much attenuated, highly attenuated, that it does not cause any interference. So as I told you in a first slide, that suppose 0 volt to 2.5 volt, right? So this is the range, this is my low signal and this is my high signal. So this particular EMI, this magnetic flux is so much attenuated that it does not affect on the values of this thing. Okay, 2.5 and 0 volt. So there are different ways of shielding, like foil braided and foil plus braided. So we'll see, one second. So let me go first. This is the outer jacket. Outer jacket is nothing but the protective shield which you have on the first wire. Then overall foil shield, this is the foil shield. Okay, then you have the drain wire. We will see what does this drain wire does. Okay, this is the function of drain wire, it sends to ground. We will see how it works. Then these are the pair of shield, you can see here. Then this is the twisted pair. So here if you see here, shielded is also there, twisted is also there, but we will discuss what twisted is doing with this, or whether we have to give the twisted pair within the shield or not. Then this is your conductor. So this is one example. Here you can see something different. So braided mesh shield, so this is the mesh, this is the mesh, or we call it braided. Okay, then you have the aluminum foil, that is foil, that is also used to, this is your insulation for the particular wire. Then this is the nothing but ground wire. Ground wire is nothing but the drain wire, also it is called as drain wire also. And these are the conductors, and this is the first layer of the environmental cover. So if you see, this is the combination of braided plus foil, and I will say this is the best solution of EMI effect to reduce the EMI effect. Okay, so you have the mass also, you have the foil also, and it will mitigate all your EMI effects. So let me move to the next slide, where we will see the three things: unshielded, foil shield, braid shield, and the foil plus braid shield. So unshielded, you know that there won't be anything, you will be having only just protective covering. Foil shield, you will be having the foil here, and foil shield is use the thin layer of aluminum, okay, which we have seen here. This is the aluminum layer of foil. Okay, and typically attached to a carrier such as polyester to add the strength and ruggedness, and it provides a 100% coverage of the conductor it surrounds, which is good. So sorry, we have seen here. So actually it provides the 100% coverage. If you can see, this is your conductor and this is your foil cell. Okay, so this is providing the 100% coverage, which is very good. And it is best if I compare with the unshielded wire. Usually, rather attempting to ground the entire shield, the drain wire is used to terminate and ground the shield. So this is your shield, and you want to ground it because you suppose some unwanted noise or unwanted signal is rushed out, and you want to ground it. So rather than shielding the complete thing, so I given one example you earlier also. So here, if you see, we are clamping the whole shield. So this is not the right way. This is not the right way. Rather, you can see here, this is my shielding, and here what I am doing with the metal cable clamp, that I am completely shielding and I am giving it to the ground through the chases. But what is the best way? You give a one drain wire, and this particular drain wire will be grounded. So this is the best way. Now coming to the braided is a woven mesh, you can see here, and this is better than this. And it is a tin copper wire. Braid provides a low resistance path to ground and much easier for the termination by crimping and soldering when attaching a connector. Braided shield do not provide the 100% coverage. So braided shield, actually, if you see, there will be some gaps would be there, and there is a possibility of incident wave or incident electromagnetic field that can pass to the conductor. So that's why this does not provide the 100% coverage. Okay, it provide around 70 to 90% coverage to the conductor. But in case of the foil, it completely covers. You can see here, it completely covers the conductor. So that's why it provides the 100% coverage. So foil shield is good, braided shield is better. Then if you are coming with the foil plus braided shield, that is the best. Okay, so if you are coming with the combination, this is the best combination where almost all the EMI effect will be mitigated. So purpose to shield is to conduct to ground any of the noise it has picked up. Okay, what is the purpose of shield? Is to conduct the to ground any noise it has picked up. So as I told you, first thing is reflect the energy, and second one is the, if anything is picked up, it should be grounded. It should be grounded. So these are the two ways, right? Then second is cable shielding, and its termination must provide a low impedance path. So low impedance path to ground, because if you have the high impedance path to ground, then it will be a problem for grounding or going that particular signal to the ground. A shielded cable that is not grounded does not work effectively. So suppose if your shielded wire is not grounded properly, then your EMI effect will not be attenuated. That is what you desire. Okay, so this is all about the EMI effect. Now coming to question on which type of shield need to be used. It depends on the environment and type of the EMI. So you cannot say that I have shown you like foil you can use, then sealed, then you can use the braided also you can use. So what type of combination you have to use, that depends on the environment. Then we came one particular thing, that is drain wire. So drain wires are used in the cable in conjunction with metal seal to ensure the effective grounding. So as I told you, this is the your the cable shield. This is the 100% termination of the ground, 360 degree termination. This is nothing but the cable shielding or the termination wire or the drain wire, you can see, that serves to complete the electrical circuit from the shield and carry a unwanted signal to the ground. So if you see here, this particular wire is actually what it doing, it is providing the effective ground. Okay, this suppose this is a shield, and this shield is connected to drain wire, and this drain wire is connected to the ground. The wire remains in contact with the metallic side of shielding tape all through the body of the cable. That places the drain wire in an ideal position to conduct a shielding cable to its ground terminal. So, as I earlier explained, radiated EMI, reflected energy, then something is remaining energy, not conducted or reflected, and this is the conducting energy, it would be very less. Something is left, then it would be grounded. Here, the same thing which I have already explained. I will not go to explanation of this thing. This is the also way of shielding. Then combination of shielding protection. So what type of shielding protection you have to use? These are the some of the combination. FUTV, UTP, that is nothing but foiled cable unshielded twisted pair. Then SUTP, shielded cable unshielded twist. SFTV, this is the best maximum EMI shielding, that is shielded and foiled twisted pair for maximum EMI shielding. This is the nothing but which I have shown you here. So here you have the braided mesh also, foil also, then you have the twisted also, twisted of the wire also. So this is the one. So you can see all these combination. These are the combination of shielding and unshielding of the cables, and different environment we use the different type of shielding. In the next video I will explain you the what is the twisting and how it use in the EMI, how to mitigate the EMI effect in the by twisting the wires. So if you like the content of this video, please like, subscribe and comment. We keep the target of 100 comment, 100 likes. Thank you for your